Good morning all. Welcome to the session 3 on system software. In the last session, we had a discussion on SIC XC machine architecture. Some of the topics just have covered. Today, just I am going to continue the same of SIC XC machine architecture. So in the last session, just I had stopped with that instruction formats. So in SIC XC machine architectures, there were 4 different kinds of instruction formats are there. Format 1, it is of 1 byte length. Format 2, it is of 2 bytes length. Format 3, it is of 3 bytes length. And format 4, it is 4 bytes of length. So as we know that whenever assembler is going to generate an object code for any program, for the higher level language program, what actually it is going to do is, it is going to generating an object code for each and every instructions. So once it has been generated all the instructions, object code for all the instructions, so then it is going to making a single file of an object file. Like an object file is to be loaded into the primary memory for its execution. In this case, for generating an object code for each and every instruction, it is using different kinds of addressing modes and different kinds of instruction format. So while it is generating an object code, first it is trying with for all the instructions with direct addressing mode with program counter relative addressing mode, because the program counter value, it is immediately available at that time. So if it is not possible with program counter relative addressing mode, so then it will go with base relative addressing mode. If it is not possible with base relative addressing mode, so then it will go with format 4, it is of 4 bytes of length. So here in the last session we had a discussion on those. So let's see what are the different kinds of addressing modes which are supported by SIC XC machine architecture. In SIC, it was supporting only 2 addressing modes, that is direct addressing mode and the index addressing mode. So the instruction format, it is only that standard instruction format, it is of 3 bytes length. But in this case, it is providing 4 different kinds of instruction formats, and also it is supporting different kinds of addressing modes. So as we know that what are the different kinds of addressing modes are there? Direct addressing mode, or it is also called as simple addressing mode, then immediate addressing mode, indirect addressing mode, index addressing mode and relative addressing mode. So the relative addressing mode is either program counter relative or base relative addressing mode. So let's discuss one by one first. First we will discuss with the last one, that is the base relative addressing mode here. So in this case, as we know that in format 3 and format 4, we are using different kinds of flag bits we are using to represent what kind of addressing mode it is. S, N, I, X, B, P, E. So last session just had I have given the brief description on those. N is for indirect addressing mode, I is for immediate, X is for indexed, B is for base relative, P is for program counter relative addressing mode, E is for bifurcating whether it is in format 3 or format 4. Right. So any combination of the bits just we can take. So if it is direct addressing mode or simple addressing mode, the N and I bit should be either 0 or 1. If both the bits are 1, the remaining bits are 0, it is purely direct addressing mode on standard SIC XC machine architecture. If both the instructions are 0, then it is direct addressing mode or simple addressing mode with SIC. So in this case, if the corresponding bit, the X bit, it is 1, if both the bits are 1, then direct addressing mode with index addressing mode. So in this case, either one of the bit, B bit or P bit should be 1, because at the same time we cannot give the both relative addressing mode. So either it should be program counter relative addressing mode or base relative addressing mode. So in this base relative addressing mode, so mainly the addressing modes, it is base relative in relative addressing mode, base relative addressing mode, and another one is program counter relative addressing mode. So in the base relative addressing mode, the corresponding B bit should be 1 and P bit should be 0. P bit should be 0. If the E bit it is 0, then it is in format 3. If the E bit it is 1, then it is format 4. in program counter relative addressing modes, then we are going to calculate the target address for this base relative addressing mode. To get the target address, both effective address and the target address are same. To get the target address here, so we should consider the displacement value. In format 3, just we are going to taking the displacement value instead of address. Instead of an address, we are going to consider the displacement value. Target address is equal to displacement plus the content of that base register. What is the content which is present in that base register at that time? So means the target address is going to be calculated by adding the displacement value plus the content of the base register at that time. So then we will get the target address. So next, if it is program counter relative addressing mode. In the program counter relative addressing mode, so here just we are taking the B bit should be 0 and the corresponding P bit should be 1. Program counter bit should be 1, base relative bit should be 0. So for calculating the target address for this, we are going to consider the displacement. Displacement is nothing but the distance between the instruction and the data variable in that particular program. So in this case, target address is equal to displacement plus, so here just we are going to consider the program counter value here. We are going to consider the program counter value. So what is the program counter? Program counter is nothing but it is a CPU register which is having a special purpose. So then it is going to pointing to our instructions to be fetched out for its execution. Right. So for calculating the target address for program counter relative addressing mode, so just we have to consider the displacement value plus the content of the program counter here, the content of the program counter. So let's discuss the different kinds of addressing modes in SICXC one by one along with an example. So for example, just we'll discuss, I'll take the example for base relative addressing mode. So let's take a simple instruction. So here just have taken the instruction here, have taken that instruction from the example, whatever the example just which has given in that textbook. So the same example just have taken. So in this case, whatever the instruction which is at the page number 60 in the textbook, the program is at the page number 60, that is the SICXC program. So just have taken the instruction which is at the memory location 1056. Which is at the memory location 1056. So what is that instruction? It is store index register value to the length. Store index register value to the length. Store instruction and load instruction. Load instruction, it is nothing but loading a value from memory location to register, storing from register to memory location. So that is the difference between load and store instructions here. So it is at the memory location 1056. So the assembler what actually is going to do is, first it is going to try to assemble. Assemble means to generate an object code for this instruction by using the program counter relative addressing mode. So if the program counter relative addressing mode, it is not possible. When it is not possible, the displacement value is more than 3 hexadecimal digits. So on that case, what actually it is going to do is, then it will go with base register addressing mode. So let us assume the program counter relative addressing mode. At that time, the program counter value is nothing but the program counter value, it is at the memory location 0003. So to get the displacement value for this instruction 1056 minus 0003, then we will get 3510. 1053 we will get the displacement value. So that displacement value we cannot fit in that of 3-bit field or 3 hexadecimal digit field in that instruction format. So hence we are going with base relative addressing mode. I will take some more example to brief about those things in later session. So 1056 is at the instruction, what is that? Store whatever the value which is present on that in that index registers to the memory variable or memory location length. So in this case, let us assume at that time the base register value is at the memory location 0033. 0033. So now the base register value, it is 00. Let us assume, it is an assumption, as that's it. So what actually it is going to do is, so here this is the length. Length is nothing but it is a memory location name. Let us assume the length is also at the memory location 0033 itself. Memory location at 33. So length is nothing but it is the memory location name. The same length value sometimes it might be loaded into the what? Base register. Base register value, it is also 00. This is the value of base register. This is the location of the length. That's it. So means in this case for this instruction, to calculate the target address. To calculate the target address, what is the formula? Target address is equal to displacement plus the content of the base register. The displacement plus the content of the base register. So what is the target address here? So where actually we have to store the content of the index register to which memory location? Length. Length is the target address. Length. We have to find where actually the length is there. So when we are looking at that program, directly we can say the length is at the memory location 33. So 0033, it comes earlier, before this instruction only. At the memory location 0033, the length was there, isn't it? So means we know that where actually the length is nothing but is the target address. What is the current instruction? Where actually the current instruction is there? At the memory location 1056. We know that base register value. What is the base register value? It is 0033. So means we should find out the displacement value. So displacement value, to get the displacement value, what we need to find out? So target address minus the content of the base register. Target address minus the content of the base register. What is the target address? The length. Where actually the length is there? At the memory location 0033. So means if you want to find out the displacement value, so 0033 minus what is the content of the base register? This is an assumption. So here 0033. So what is the displacement value? 0. What is the displacement value? 0. So means the same thing is going to be represented. By using the instruction format. So whatever the instruction it might be, the assembler is trying to get the object code by using format 3 along with what? Direct addressing mode with program counter relative addressing mode. If it is not possible, so then it will go with direct with base relative. If both are not possible, so then it will go with format 4. Right. So in this case, so the instruction format is like this. Right. So it is of 24-bit length. The 6 bits, it is an opcode. The opcode for STX is at the page number 470. The what opcode for STX is 10. The opcode for STX, it is 10. So just I am going to writing 0001 0000, 2 hexadecimal digits. The opcode it is nothing but it is 2 hexadecimal digits. So the next 6 bits or the flag bits to represent the addressing mode, to get an object code for that particular instruction, that is STX length. So this is all is going to be done by an assembler. So here just it is going to identifying on which addressing mode that instruction is there. Yes, of course it is using base relative addressing mode. So means direct with base relative addressing mode. So the corresponding B bit should be 1 since it is direct addressing mode. So means we need to change N bit and I bit should be 1. We need to change the N bit and I bit should be 1. So the X bit should be 0 because there is no index register here in this instruction in the operand field, not in operator field. We have to look for that index register in the operands field. So here X register should be 0. Means for this instruction the program counter relative it is not possible. So hence it will go with base relative addressing mode. So means B bit should be 1, P bit should be Either B bit should be 1 or P bit should be 0. When it is P bit should be 1, so then B bit should be 0. So now if it is in format 3, the corresponding E bit should be 0. Right? So these are the 1 bit each, right? There are 6 bits. So these 6 bits which is used to represent an opcode. So the remaining 12 bits, which is used to represent the displacement. What is the displacement value we got here? 0. So means it is of 12 bits of length, 3 hexadecimal digits for zeros just we need to write. So means 0, 0, 0 like this. So just we have to write like this, right? So here after that, so this is how actually it is going to get all the informations by using the instruction format. After this, it has to grouping 4 bits to form a single hexadecimal digit to get an object code here. So means combining those 4 bits here, 4 bits each. After putting all those things, so just we need to grouping 4 bits of each. For each 4 bit, just we have to write its corresponding hexadecimal digit. So for hexadecimal digit, it is of 134, 0, 0, 0. So means there are 6 hexadecimal digits are there. So what is the length of an object code? It is 3 bytes. So this is how actually we can calculate the base relative addressing mode here. The base relative addressing mode. So next, the program counter relative addressing mode. Please do remember, the assembler is trying to get an object code by using the program counter relative addressing mode first. So if it is not possible, then it will go with base relative addressing mode. So next, we will discuss that program counter relative addressing mode. So I will take another example from the same program. I will take another example for program counter relative addressing mode. The program counter relative addressing mode. For example, just I am taking an instruction STL, store linkage register value to the memory location return address. Store linkage register value what? To the memory location, what? Return address. Let us assume in that program this instruction is at the memory location 0. So in the same program, what is the target address? So means what actually it is saying is this instruction, the linkage register value, I don't know what value it is there in the linkage register. So whatever the value which is present in the linkage register, that linkage register value must be loaded to the memory location, that is return address. This is the memory variable name. Let us assume the return address is at the memory location 0030. So here at the memory location 0030, what actually it is there? The return address. Whatever the memory variables just we are using, all the memory variables should be there in the label field in that program. So return address, where actually it is there at the memory location is something, it might be word or some kind of byte and whatever it might be. So means what we need to do is, so whatever the link, what actually this instruction is saying is, whatever the value which is present in the linkage register must be stored to the return address, where actually the return address is there at the memory location 0030. Which instruction it needs to be executed? So the program counter is pointing to this instruction. It is already fetched out. So once the instruction is fetched out, immediately the program counter value must be incremented. So means it is going to be pointed to the next instruction. So now what is the program counter value? So just it is going to point into the next instruction is at the memory location 0003, because we are incrementing the memory location by 3 bytes, because the instruction length in SIC, XC or in SIC, some of the instructions it is of 3 bytes length. So hence the memory location value is obviously it is incremented by 3 bytes. If it is what format 4, so then the memory location value or program counter value must be incremented by 4 bytes, because the length of that instruction, it is of 4 bytes only. So means the program counter, what is the program counter value? What is the program counter value? It is 003, right? So we know that target address, what is the target address? Return address, where actually the return address is there? At the memory location 0030. Return address is the target address. So what is the memory location? 0030. So means to get the target address, the formula is for program counter relative addressing mode, displacement plus the content of the program counter. Displacement plus the content of the program counter. So what is the displacement value? I don't know. So means we need to find out the displacement. Displacement means what? So this is the instruction needs to be executed. So for executing this instruction, from where actually it has to fetch the memory or value? So from here, right? So the instruction it needs to be executed is at the memory location 0000, where actually it is going to referring the instruction is at the memory location memory location at 0030. So means the distance between these two instructions is called as displacement. The distance between those two instructions, it is called as displacement value. So means to get the displacement value, I need to subtract the current program counter value from the target address. Current program counter value from target address. So then we will get what? The displacement value. Displacement is nothing but this is the instruction needs to be executed, which is at the memory location 000. To which memory location it is going to refer? At the memory location, the what memory variable which is at the memory location 0030. So to get this value, it has to get the displacement value, means it has to know where actually the instruction or memory variable it is there in that particular program. So means what actually it is going to do is, so means it has to find out the displacement value. We know the target address. What is the target address? 0030. So what is the program counter value? Once the instruction is fetched out, immediately the program counter will be incremented, will be pointing to the next instruction. Next instruction is to be fetched out. So means the program counter value it is 0003. So means to get the displacement value here, to get the displacement value, now it is 0030. That is the target address minus the content of the program counter 0003. So this is the hexadecimal what arithmetic operation or subtraction here, right? Hexadecimal value, the carry value it is 16, right? 16 minus 3 it is 13. 13 is nothing but D, right? From 10 to 15. So just we are using the alphabets A, B, C, D, E, F like that. So means just we are going to subtracting 3 from 0030. Just we are going to subtracting. So from 0 we cannot subtract. So hence we have to get the borrow here. So what is the borrow value? 16. 16 minus 3 it is 13. 13 means in the hexadecimal value it is D. So what is the remaining value? 2. What is the displacement value? It is 02D. 02D is the displacement value here. 02D is the displacement value. So to get an object code for this instruction, so as of course we are using the instruction format here by using format 3, right? So what is the opcode? What is the instruction? Just we are using store linkage register, that is the STL. So what is the linkage register value STL? The opcode is nothing but 14. The opcode for STL it is 14, which is at the page number 470, 471 like that. So here 14. So just I am going to writing 0001 01 00. So now I am using the program counter relative addressing mode. The corresponding P bit should be 1. Since it is format 3, the corresponding E bit should be 0. P bit should be 0. It is not having any index register in the operand field. So hence the index register value it is also 0. Right. So what is the displacement value? 02D. So here 0 to D. D means 13. 13 means 8 plus 10, 8 plus 4, 12, 12 plus 1, 13. Right. So now just we have to group 4 bits each to get an object code for that instruction. So this is 1. So now the corresponding, since it is direct addressing mode, so we are using the corresponding, we are changing the corresponding n bit and I bit should be 1. So since it is SIC exclamation architecture. So 1, this is 7, 0, 1, 1, 1, it is 7. So next it is 2, next 0 to D. So what the object code for this instruction, it is 1, 7, 2, 0, 2D. This is an object code which is being generated by an instruction, by an assembler, that object code. So this object code is going to be loaded at the memory location 0000. This is logical address. At the loading time, the physical address, we will get the actual physical address by using some kind of relocation concept and all. So this is how actually we can get the program counter relative addressing mode and base relative addressing mode. So then we'll take one more example on the same by using the index register, index addressing mode with direct addressing. So first the assembler is trying with direct addressing mode along with the program counter relative addressing mode. So if it is not possible with the program counters, so then it will go with base relative addressing mode. So what actually it is going to be done for this instruction? This is the instruction needs to be executed. So means for this instruction, the assembler needs to generate an object code. So for generating an object code for this instruction, what actually it is going to do is, so means first it has to find out the target address. So what is the target address? Buffer. So this instruction, just you can observe that, so store character to the buffer along with the indexed value. I don't know what other index register it is having. So because if it is representing in the form of arrays, so each position of an array just we are going to representing by using its index value. So let us assume the buffer is capable of holding 100 characters. The buffer is capable of holding 100 characters. So let us assume the buffer, the memory location which is at the memory location 0036. Which is at the memory location 0036. Let us assume buffer it is capable of holding 100 bytes of information. So means it's been started with 0036. If it is 100, it is being ended by plus 100 0136. So means the index register value, it is being what? Index the position of this buffer x is equal to 0, 1, 2, 3, 4, 5 like this. So means at that time whatever the index register value means we need to consider that index register value also. So in this case this instruction needs to be executed. For this, first the assembler what actually is going to do is it is going to finding out what the object code by using what direct with program counter relative addressing mode. So here what is the program counter value at that time? So the program counter is pointing to this instruction is to be fetched out. Immediately the program counter value is going to be incremented. So plus 3. So plus 3 means it is nothing but 14. 14 plus 3 it is 17. 17 is nothing but what? If it is what? 1 1. So here 1 5 0 1. So means now the program counter value it is 1051. It is the program counter value. So means to get the displacement value, whatever the value just we are getting here. So either we can get the negative value or positive value. So whatever the value it might be, negative value or positive value, but the number of bits it should not be exceeded than 3 hexadecimal digits, that is the displacement value. So here if I want to get the target address or displacement value, so now I need to subtract the program counter value from the target address. For this instruction what is the target address? Buffer. Where actually the buffer is there? At the memory location 0036. So 0036 minus what is the program counter value at that time? 1051. 1051. So if I am subtracting a smaller number from the bigger number, I will get some 4 digits number here. So if I want to convert the same thing into a 2's complement or negative number, there also I will get 4 digit hexadecimal digits only, 4 digit negative number. So hence for this instruction what the program counter relative, it is not possible because it is going to refer the backward reference, not forward reference. If it is forward reference, then it will be okay. If it is backward reference, the displacement is too high if it is program counter. So in the same program, let us assume the base relative value, it is 0033. So now we can get the displacement value here. So what is the displacement value? What is the target address? Is 0036. Buffer target address is 0036. So next, what is the content of the 0036 minus what base register value, that is 0033. So what is the displacement value? 0003. So this is the displacement value. Easily I can fit this displacement value in the displacement field in that what format 3 instruction format. So means what actually it is going to telling is, so this store character means whatever the accumulator it is having some kind of character. Accumulator is having some character. So let us take an accumulator is having a character C. That character must be loaded. Let us assume at that time the index register value it is 3. So means index register value means 3 means here it will come, right. So index register value it is 3. So means store the character which is present in an accumulator. Let us assume accumulator it is having a character C. So to the buffer at the index register value, what is the index register value? It is 3. So means to get the target address for such kind of things, so here the displacement value like this. So the target address we are going to calculating the displacement plus the what displacement plus the content of the base register. Since it is index register mode, so hence we have to consider the content of the index register also. So means to this instruction it needs to be, so means to this position it has to be inserted means 0036 plus 3, right, 0036 plus 3. So means it is 0039. To the position 0039 the character must be inserted. Means, so what is the displacement value? 003. What is the content of the base register? Base register it is 0033. What is the content of the index register? So just we are assuming at that time the index register value, the position of that array is at the position 3. So means plus 3. So means what is the memory location? 3 plus 3 plus 3 it is 9. Next it is 300. So to this memory location the instruction whatever the character is there it must be stored. So means the same thing is going to be represented by using the instruction format like this. So here the opcode. So here just we are going to using the thing. So here the opcode for STCH54. The opcode for STCH it is 54 0101 0100. So here since we are using the base relative addressing mode, since it is format 3, so the program counter it is 0, yes, of course we are going to considering the index register also, because you can see the index register is also there in the operand field, not in the operator field, in the operands field. So means the corresponding x bit should be 1. So means while decoding that instruction, so means it has to consider the base register value, index register value, displacement value to get the actual physical address of that particular variable like that. So means after that what is the displacement, what is the displacement value we got here? 003. Directly just have written like that, that is the hexadecimal digits. So then to get, since it is direct addressing mode, so hence of course the corresponding n bit and I bit should be 1. So here just we have to what? Get the value, that is 5, 7, 12. 12 is nothing but it is C 003. So means 57C003 is an object code for this instruction. That object code it must be loaded at the memory location 104A. This is the logical address. Physical address will be changed at the loading time, right? So this is how actually we can get an object code for each and every instructions of that particular program. So let's have some of the examples we will take how to decode what the instruction and to get the target address by using a different example. So here let us assume just I'll have a memory structure here. I'll have a memory structure, right? Is that the memory location 3030? So some value which is there 3600. It might be another memory location or some of the value it might be. So let us assume at the memory location 3600. So some value which is there, that is 103000, whatever it might be. So next at the memory location 6390. At the memory location 6390. So some value which is there 00C303, some of the value, and at the memory location C303 is at the memory location some value which is there 003030. So let us assume the program counter value and the base register value and what base relative, program counter, the index register value. So the index register value it is 00090, 00090. Again for the base register it is 00600. This is an assumption, that's it, right? For program counter value it is 00300. So this is the example just I have taken. So for the exam sake, so they will give some kind of what object code. For that object code, so just you have to decode it, then you have to find out the target address. After that just you have to find out which value is going to be loaded into the memory variable as in some registers. So for that purpose just I have taken this kind of example here. So let us take the instruction, that is the object code instruction. So just I am taking 0326600. So this is an object code. I don't know for which instruction that object code it is. So means this object code must be decoded. We have to find out the target address. Again we have to find out which value is going to be loaded into the register or some memory location. So means when we are looking at this instruction, easily we can say that this instruction it is of 3 bytes length. If it is 3 bytes length means it is format 3, isn't it? It is format 3. That format 3 means 3 bytes, whether it might be SIC or SIC XC. So first what we have to do is, so whatever the instruction it is there, so here this instruction it is composed of 6 hexadecimal digits. So first we have to decode each hexadecimal digit into its binary code of 4 bits, right? So 0, just we are taking 0. For 3, 0, 0, 1, 1. For 2, 0, 0, 1, 0. For 6, it is 0, 1, 1, 0. For 2 zeros, just we are taking 0, 0, again 0, 0, 0, 0. Right? So this is the how actually we can decode that one. So here how many bytes are there? 3 bytes. So for each hexadecimal digit it is of 4 bits of information. So after that, so it is in format 3 instruction format. It is in format 3 instruction format. So means we have to separate the bits, the first 6 bits which is used to represent an opcode. So the next bits N, I, X bit, B, P, E. The remaining bits is nothing but it is displacement value. So this is how actually we can decode that instruction. So means what actually we can do is, after doing this one, so just we have to find out the target address. How we can find out the target address? Target address is nothing but, so means displacement value. So means we have to find out the displacement value. After that we need to find out which addressing mode it is, the instruction is on, right? So how actually we are going to find identifying the addressing mode? By observing the bits of these flag bits, that is N, I, X, B, P, E. If N bit and I bits are 1, N bits or I bits of 1 means what? it is direct addressing mode or simple addressing mode in SIC-XC format, in SIC-XC. So after that, the X bit it is 0 means we should not consider the indexed value, index register value. If the B bit it is 0, we should not consider the base relative. The corresponding P bit it is 1 here, so means it is direct with program counter relative addressing mode. It is direct with program counter relative addressing mode. So means since that E bit it is 0 means what? Means what? So here is nothing but it is in format 3. So means we need to get the target address, we need to consider the displacement value plus the content of the program counter because it is direct addressing mode. It is direct addressing mode, the content of the program counter. So here they have given the program counter value here. We know that the displacement value. What is the displacement value? 600. 600 it is a displacement value. What is the content of the program counter? 0030000, isn't it? So means the target address is nothing but 3600. So means the target address for this instruction, it is pointing to this position. And whatever the instruction, just it has been written in that assembly level language, that instruction is going to be executed, storing or loading and whatever it might be. So by looking at this 00 means N and I bit it is 11 means just we have to make it as 00 here. 00 means load accumulator. Load accumulator with the value which is present at this memory location. So means accumulator must be loaded with this value. Load accumulator must be loaded with this value. What is the memory location? 3600. Let us take another example here for the same. Let us take another example. Another instruction, the object code instruction. So directly I am taking another example 03C 300. So first whatever the instruction it might be, so first you have to decode it. So how actually you are going to decoding is 0 means 4 binary bits for each hexadecimal digit. So 0, 3, C means it is 12, that is 1100. For 3 it is 0011. For 0 it is just 0, 3, 12, 3, 0, 0. So this is, so when we are looking at that one, so as obviously it is in format 3, we should know what kind of addressing mode it is. Again, so just we are going to separating those bits and along with the displacement value, this is opcode. N and I bits or N and I bit or 1. Here just look at that one. Index register value it is 1 and the base relative value it is 1. Index register value it is 1 and base register value it is 1. So means to get the target address, we have to consider the displacement value plus the index register value plus the content of the base register value at that time. All the values must be considered. Displacement, the corresponding B bit it is 1, corresponding X bit is 1 here. So means it is direct addressing mode along with index and base relative. So means displacement, what is the displacement value? It is 300, right? So what is the index register value? What they are given there? 006000. So what is the base register value? It is, what is the base? Sorry, this is the what? Base register value. This is the index register value, right? So 00600, what is the index register value here? 000090. By adding up those things, so here 000300, again 600, again 90. So means 0936 6390. So this is the memory location. This is the target address. This is the target address, so means it has to fetch. So just you look at this instruction, if both the bits are of 0, so then this instruction, the opcode, it is load A, that is load accumulator. Load accumulator along with load accumulator, so means load an accumulator value which is present at the memory location 6390 here, 6390. So means the accumulator will be loaded with the value which is present at the memory location 6390. That value must be loaded into an accumulator. So this is how actually we can decode the instruction. I am winding up this session today. In the next session, just I will come up with some more SIC and SIC XC programming examples. Thank you.